welcome you all in today's NPTEL online certification course lecture on mechatronics. Today I am going to talk about the input output systems and the communication systems. Okay, so here I am going to talk about the two aspects basically. As I said, communication system means how the devices communicate through each other, and the input output means the connection of these input and output devices, okay, through to the microcontrollers, okay, or microprocessors. So, when a microprocessor is used to control some system, it has to accept the input information, okay, respond to it and produce an output signal to implement the required control action. This is ideally what happens actually. So, there could be input from sensors to feed data to microprocessor and output from microprocessor to external devices such as relays, motors and so on. Now, peripherals such as sensors, keyboard, actuator, etc. These are what we call we mean by the peripherals. Now, due to different signal forms and levels, peripherals cannot be directly connected to the microprocessor. So, a circuit called an interface is required. Now, while connecting, we need to address the input and output. Okay. So, microprocessors have special input instructions and the output instructions. Microprocessors use parallel ports to input or output bytes of data. Now, what could be the interface requirements? As I said, we cannot connect the peripheral devices directly to a microprocessor or microcontroller. Okay. So, it has to be done with the help of a certain interface. Okay. So, what could be these interface requirements? Okay. So, first requirement could be say electrical buffering and isolation. Okay. When peripherals operates at a different current or voltage that on the microprocessor bus system, or there are different ground references, then we require electrical buffering or isolation. Now, next is for the timing control. It is needed when the data transfer rates of the peripheral and the microprocessor are different. Okay. So, that is interfacing a microprocessor to a slower peripheral. Now, this can be achieved by using special lines between the microprocessor and the peripherals to control the transfer of data. Such lines are called handshake lines, and the process is called the handshake. Next is the code conversion. This is required when the codes used by the peripherals are different to that used by the microprocessor. Then we we have a requirement of the conversion of the code. Okay. Or we could also have the requirement of changing the number of lines. Okay. So, microprocessor uses 4 bits or 8 bits or 16 bits. So, this determines actually the number of lines in microprocessor data bus. Okay. Peripherals may have the different number of lines. So, we may require to change the number of lines. Serial to parallel and vice versa data transfer. A 8-bit microprocessor manipulates 8 bit of data at the same time. Now, this can be done by parallel data transfer, where all the data are sent simultaneously, whereas in serial data transfer signals are sent one by one. Okay. And we may have the conversion from analog to digital or digital to analog. We have seen already these devices in my earlier lectures. Then buffers, okay, it does not change the logic of the input, but just changes the current or voltage levels, okay, and we can use amplifier for this handshaking. Okay. As I said, unless two devices can send and receive data at identical rates, handshaking is necessary to exchange data. With handshaking, the slower device controls the rate at which the data is to be transferred. Okay. And for parallel data transfer, stroke and acknowledge is commonly form of data transfer. Polling and interrupts. The process of repeated checking each peripheral device to see if it is ready to send or accept a new byte is called polling. Okay. And an alternate to program control is the interrupt control. Okay. And here basically a signal of interrupt causes microprocessor is suspending the execution of the main program and jumping into the service routine for the peripherals. Serial interfacing. With parallel transmission, one line is used for each bit, okay, and in serial interface system they use a single line to transmit data in sequential bits. Okay. So, the two forms of serial data transfer are there, asynchronous and the synchronous. Okay. So, the asynchronous one use their own clock, have own start and stop bit, whereas the synchronous one, as the name indicates, they use the same clock. Peripheral interface adapters, or in short they are also called as PIAs. So, interfaces can be designed for a particular input output. Programmable input output interface devices are available which permits different input output options to be selected by the software. Such devices are called PIAs, and a commonly used PIA parallel interface is Motorola MC6821. Okay. This is the schematic of the MC6821 PIA, basically where you can see that there are various type of register, output register B, A, control register are there. Okay. Chip select, read and write control. Okay. Bus input register, data bus buffer are there. Okay. And here you have the input output data port A, input output data port B. Okay. So, this is peripheral interface A and this is peripheral interface B. It has the control lines here CA1, CA2 as well as CB1 and CB2. Okay. Here they have the interrupt status control, over here. The PIA contains two parallel data ports termed A and B, and each port has a peripheral interface register, a data direction register and a control register, and the two control lines CA1 and CA2 and CB1 and CB2 are there. There are microprocessor address line RS0 and RS1. Initialization of peripherals. Okay. So, the program runs once, placed at the beginning of the program, and we can connect interrupt signal via the PIA. Now, let us look at the communication systems. Okay. So, those who are interested in further reading, you can refer to mechatronics by Bolton. Okay. So, I have just given a very brief idea about these input output devices as well as the communication systems. You can have the further reading from that particular textbook. Now, coming to the communication system, as I said, the devices has to communicate. Okay. So, an external bus is a set of signal lines that interconnects microprocessor, microcontroller, computer and PLCs, and also connect them with the peripheral equipments. Okay. And for example, in a car there are likely to be several microcontrollers, each controlling a different part of the system. Okay. Say engine management system, braking system, instrument panel, communication between them is necessary. Centralized computer control. Okay. So, now let us look at this. Now, the centralized computer control involves the use of one central computer to control an entire plant. Okay. This has the problem that the failure of the computer result in the loss of control of the entire plant. Okay. And this can be avoided by the use of dual computer systems. Such centralized systems were common in 1960s and 70s, and the development of the microprocessor and the ever reducing cost of the computer have led to the multi-computer system becoming more common and the development of hierarchical and the distributed system becoming more common these days. Now, let us look at the hierarchical system. Okay. With the hierarchical system, there is a hierarchy of computers according to the task they carry out. Okay. The computer handling the more routine tasks are supervised by computers which have a greater decision making role. Okay. For example, the computer which are used for direct digital control of systems are subservient to a computer which performs supervisory control of the entire system, and the work is divided between the computers according to the function involved. There is a specialization of computers, with some computers only receiving some information and the other the different information. Now, let us look at the distributed system. With the distributed system, each computer system carries out essentially similar tasks to all the other computer systems. Okay. And in the event of failure of one, okay, or overloading of a particular computer, what can be transferred to the other computers. The work is spread across all the computers and not allocated to specific computers according to the functions involved. There is no specialization of computers over here. Okay. Each computer thus need access to all the information of the system. The modern systems, there is generally a mixture of distributed and the hierarchical systems. Okay. For example, the work of measurement and actuation may be distributed among a number of microcontrollers, computers which are linked together and provide the database for the plant. These may be overseen by a computer used for direct digital control or sequencing, and this in turn may be supervised by one used for supervisory control of the plant as a whole. Now, these distributed or hierarchical systems have the advantage of allowing the task of measurement, scanning and the signal conditioning in control system to be carried out by sharing it between the number of microprocessors. This can involve a large number of signals with a high frequency of scanning. If extra measurement loops are required, it is a simple matter to increase the capacity of the system by adding microprocessors. Failure of one unit does not result in the failure of the entire system. here. And if we look at the ways of communication, there are essentially two ways, as I discussed earlier, the parallel data transmission and the serial data transmission. Okay, parallel data transmission, as I said, you have the parallel lines basically, and in case of the serial data transmission, we could have the simplex mode or a half duplex mode or the full duplex mode. Okay, I will be discussing about all these ways. So, first of all, let us look at the parallel data transmission. Okay. So, the parallel data transmission, in this case 8, 16 or 32 bits can be transmitted simultaneously, and they have a separate bus for each data bit and the control signal. Okay. So, suppose if I have got a 8-bit data bit to be transmitted, say this is just for example. So, you have 1, 2, 3, 4, 5, 6, 7, 8, this 8-bit data is to be transmitted. Okay. Then 8 wires are needed basically. Okay. One wire for the each bit, and the entire 8-bit data are transmitted in the at the same time as it takes to transmit one data bit, because each bit is on a parallel wire. Okay. And the parallel data transmission permits high data transfer rate, because you can transmit the each data simultaneously, and it is expensive because of the cabling and interface circuit requirements basically. It is normally only used over short distances or where high transfer rates are required. Next, let us look at the serial data transmission. Okay. So, as the name indicates, the transmission of data occurs together with control signal and sent bit by bit in sequence through a single line. Okay. So, this is the feature of the serial data transmission. Everything has to be transmitted through a single line. So, only two conductors are needed to transmit data and to receive data. Since the bits of words are transmitted sequentially and not simultaneously, the data transfer rate is considerably less than with the parallel data transmission. It is quite obvious. However, it is cheaper since far few conductors are required. For example, with a car, when a number of microcontrollers are used, connection between them are by serial data transmission. Without the use of serial transmission, the number of wires involved would be considerable. Okay. And the serial data transmission can be either asynchronous or it could be synchronous in nature. Okay. That is, they could have the different clocks or they could have the same clock. So, asynchronous transmission basically it implies that both the transmitter and receiver computers are not synchronized, each having its own independent clock signals, as I just told you. Okay. And the time between the transmitted characters is arbitrary, and each character transmitted along the link is thus preceded by a start bit to indicate to the receiver the start of a character, and followed by a stop bit to indicate its completion. Okay. And this method has the disadvantage of requiring extra bit to be transmitted along with each character, and thus reduces the efficiency of the line for the data transmission. With synchronous transmission, there is no need for start and stop bit, since the transmitter and receiver have a common clock signal, and thus character automatically start and stop always at the same time in the each cycle. Now, let us look at the rate of data transmission. Okay. The rate of data transmission is measured in bits per second. if a group of n bits form a single symbol being transmitted and the symbol has a duration of t second, then the rate of data transmission is basically n by t, and the baud rate is the unit used. So, the baud rate is only the same as the number of bits per second transmitted if each character is represented by just one symbol. Thus, a system which does not use start and stop pulse has a baud rate equal to the bit rate. Now, let us look at the serial data communication mode, the three modes which I have talked to you. The simplex mode, it is basically only one way transmission from say A to B. So, the transmission is only possible in one direction from device A to device B, where device B is not capable of transmitting back to device A. This method is usually used for transmission to devices such as printers, which never transmit the information. Then we have the half duplex mode. So, here the data is transmitted in one direction at a time, but the direction can be changed actually, and the terminals at each end of the link can be switched from transmit to receive. So, thus device A can transmit to device B and receive device B to device A, but not at the same time. So, basically it can do either transmit or receive, both cannot be done simultaneously in case of half duplex mode. In case of full duplex mode, data may be transmitted simultaneously in both direction between A and B. So, here in the full duplex mode, it could be either A to B, or we can also have B to A basically. So, this is like the two-lane highway in which the traffic can occur in both directions simultaneously, and the telephone system is an example of full duplex mode, in that a person can talk as well as receive at the same time. Now, let us look at the networks. Network is used for a system which allows two or more computers or microprocessor to be linked for the interchange of data. So, these are the some of the common forms of the network. I will be talking details about is this is the data bus, this is the star configuration, this is the hierarchical, this is the ring, and this is the mesh. In case of the data bus, this has a linear bus into which all the stations are plugged basically, and this system is often used for multi-point terminal clusters, and it is generally preferred method for distance between nodes of more than 100 meter. Then the star configuration, this is this has dedicated channel between each station and the central switching hub through which all communication must pass. This is the type of network used in the telephone system, all the lines passing through the central exchange. The system is also often used to connect remote and local terminals to a central mainframe computer. There is a major problem with this system is that if the central hub fails, the entire system fails, in this case of the star form of network. Then next is the hierarchy or the tree network. This consists of series of branches converging directly to a point at the head of the tree. With this system, there is only one transmission path between any two stations, and this arrangement may be formed from a number of linked data bus system. Like the bus method, it is often used for distances between more than 100 meters. The ring system, ring form is a very popular method for the local area network or the LAN, involving each station being connected to a ring. The distance between nodes are generally less than 100 meter, and data input into the ring system continues to circulate around the ring until some system removes it. The data is available to all the stations. And next is the mesh form, and this form has no formal pattern to the connection between the stations, and there will be multiple data paths between them. The local area network or the LAN is used for a network over a local geographic area such as building or group of building on one side. The topology commonly used is bus star or the ring one, and the wide area network is one that interconnects computer terminal and local area network over a national or the international level. Now, let us look at the serial communication interfaces. Okay. So, the serial interfacing can involve synchronous or asynchronous protocols. Commonly used asynchronous interfaces are RS-232, the 20 milliamp current loop, I2C CAN, and the USB. Let us look at first the RS-232. The most popular serial interface is RS-232. This was first defined by the American Electronic Industries Association EIA in 1962. The RS-422 similar to RS-232 uses a pair of lines for each signal and can operate up to about 1220 meter or higher transmission speeds up to 100 bits per second and in noisy environments. Maximum speed and maximum distance cannot, however, be achieved simultaneously. Similar is the case with RS-485. So, this is how the RS-232 minimum configuration looks like. Basically, we have the data terminal equipment over here and data circuit terminating equipment here. Okay. So, we could have the transmitted data from 2 and 3 could have have the received data. Okay. So, similarly, we have 2 transmitted data and 3 have the received data, and the 7 port is the common ground. Next, let us look at the 20 milliamp current loop. This uses a current signal rather than a voltage signal. A pair of separate wires is used for the transmission and the receiver loops, with the current level of 20 milliamps used to indicate a logic 1 and 0 milliamp for logic 0. Okay. So, 20 milliamp for logic 1 and 0 milliamp for logic 0. The serial data is encoded with a start bit, 8 bit and the 2 stop bits. Such current signals enables a far greater distance, a few kilometer, between transmitter and receiver than with the standard RS-232 voltage connections. So, this is how we have the 20 milliamp transmit. Okay. So, you have current detector and this is how this 20 milliamp current loop works. Next, let us look at the I2C bus. The inter-IC communication bus is a serial data bus designed by the Philips and it is used for the communication between integrated circuits or the modules. The bus allows data and instruction to be exchanged between devices by means of just 2 wires actually, and this results in a considerable simplification of the circuit. The 2 lines are a bidirectional data line and a clock line. Both lines are connected to the positive power supply via resistors. The device that controls the bus operation is the master, and the device which are controlled by the masters are the slaves, and the following is the protocol used. When both the data and clock lines are high, the bus is not busy. A change in the state of data line from high to low while the clock is high is used to define the start of the data transfer, and a change in the state of data line from low to high while the clock is high defines the stop of the data transfer. Data is transferred between the start and the stop conditions. After a start of data transfer, the data line is stable for the duration of the high period of the clock signal, being able to change during the low periods of the clock signal. There is one clock pulse per data bit transferred with no limit on the number of data bytes that can be transferred between the start and stop conditions. After each byte of data, the receiver acknowledges with 9th bit. The acknowledge bit is a high level put on the bus by the transmitter, a low level by a receiver. Next, let us look at the CAN bus, okay, that is the controller area network bus. CAN is a multi-master serial bus standard for connecting ECUs. Each node in the system is able to both end and receive messages and requires the following: a host computer, a CAN controller and a transceiver. Next, let us look at the USB, okay, the universal serial bus, the very popular form. Okay. So, the universal serial bus or USB is designed to enable monitors, printers, modems and other input devices to be easily connected to the PC. The term plug and play is used. USB uses a star topology, thus only one device needs to be plugged into PC, with other devices then being able to be plugged into the resulting hub. So, resulting is a tiered star topology. The low speed version USB 1.0 specification was introduced in 1996 and has a transfer rate of 12 megabits per second and is limited to cable length of 3 meters. The next version was USB 2.0, which was introduced in April 2000 and has a data transfer rate of 480 megabits per second and is limited for the cable length of 5 meter. And then we have the USB 3.0, okay, also came with a data transfer rate of 4.8 gigabits per second. Firewire is a serial bus developed by Apple Computers. The specifications were given by IEEE 1394 and it offers plug and play capabilities and is used for applications such as disk drive, printers and cameras. Okay. The parallel communication interface, as I said, the most commonly used parallel interface in communication is the general purpose instrument bus, that is GPIB, developed by HP to link its computer and instruments and thus often referred to as HP instrumentation bus. Each of device connected to the bus is termed listener, talker or controller. Listeners are devices that accept basically data from the bus. Talkers place data on request on the bus and controllers manage the flow of data on the bus by sending commands to talker and listeners and carry out polls to see which device are active. Okay. So, this is all about this these two lectures, okay, and you can further read if you are interested about this in Bolton as I indicated earlier, okay, and thank you and good luck.